Hello students, I hope you are doing well and you are getting enough study material as we are trying our best to provide you best material ever. So I am here with new lecture on chapter electrochemistry, and today's topic is molar conductance. What does molar conductance means? I told you that conductance of a solution depends upon number of ions present in the solution, because ions are the current carrier. So in a solution, if there are more number of ions, there will be high conductance in it. Molar conductance means the conducting power of all the ions which are obtained by dissolving 1 mole of electrolyte. What I am saying, if we are dissolving 1 mole of electrolyte, okay, and 1 mole of electrolyte will give any number of ion, I say, because it totally depends upon the type of salt. So 1 mole electrolyte को dissolve करने पर solution की जो भी conductance होगी, that is called molar conductance of the solution. Molar conductance is denoted by letter lambda m. It is denoted by lambda m. This letter is called lambda, and we are writing in subscript small m, and for molarity. So molar conductance is denoted by lambda m, and mathematically lambda m is equal to kappa into volume. Kappa into volume of solution in ml, that is the volume. Kappa, I told you, kappa is called conductivity or specific conductance, and V is volume of solution. In ml. Okay. So how does it related with molarity? We will see this. Since we know that molarity of a solution is number of mole and volume of solution per liter, if the volume is given in ml, we will multiply 1000 over here. Okay. So in the case of molarity, we know that number of moles of electrolyte or number of moles of solute upon volume. Okay. But here we know that we are taking 1 mole of electrolyte. So the number of mole means the value of m will be 1, and we have m is equals to 1 upon V multiplied by 1000. Now what is the value of V? How we can find out V? A very simple thing. V is equals to, there will be 1000 upon m. Okay. Molarity is type of concentration, so we can also write the volume is equal to 1000 upon concentration. The C stands for concentration. Okay. So the now final formula that we will get over here by replacing the value of volume in the formula of this. So we will get lambda m is equals to kappa into molarity, kappa into 1000 upon m. Okay, kappa into 1000 upon m. Since we know that normality is also type of concentration, because we have written concentration over here, and we know that the normality is also a concentration, and normality is calculated by equivalent weight. So in this case, if we are using normality in the place of molarity, if we are using normality, I'm talking about capital M. If we are using normality, then the molar conductance will called equivalent conductance. It will be called equivalent conductance, and the symbol is lambda E is equals to kappa into 1000 upon n, where n is normality and lambda E is called equivalent conductance. So we have got two formulas over here. First the lambda m and the second is lambda e. Okay. Now we will see the effect of dilution or effect of change of concentration of इलेक्ट्रोलाइट सॉल्यूशन ऑन मोलर कंडक्टिविटी. इट मींस अगर हम इलेक्ट्रोलाइटिक सॉल्यूशन का कॉन्सेंट्रेशन चेंज कर दें, उसके कॉन्सेंट्रेशन को कम कर दें या ज्यादा कर दें, तो उससे मोलर कंडक्टिविटी पर क्या इफेक्ट होता है. बिफोर वी सी द इफेक्ट ऑफ डाइल्यूशन और चेंज द कॉन्सेंट्रेशन ऑफ इलेक्ट्रोलाइट सॉल्यूशन ऑन मोलर कंडक्टेंस, वी विल सी द यूनिट्स ऑफ मोलर कंडक्टेंस. लैम्डा m has unit ohm inverse centimeter square into mole inverse. That is the unit of lambda m, I mean molar conductance. And SI unit, standard unit, is Simon meter square into mole inverse. This is the unit of molar conductance. Okay, now we will see what happens when the solution of an electrolyte is diluted. There are two cases. I am talking about effect of dilution. On molar conductance. Okay, there are two cases of dilution of solution of electrolyte. First we are taking for strong electrolyte. Okay, and second for weak electrolyte. If we talk about strong electrolyte, I told you one thing about strong electrolyte, that strong electrolyte are 100% ionized or 100% dissociate in aqueous solution, while weak electrolyte do not dissociate up to 100% in aqueous solution. Strong electrolyte dissociate बहुत ज़्यादा हो जाते हैं, 100% तक dissociate होते हैं. weak electrolyte के केसेस में ऐसा नहीं है. तो अगर हम सॉल्यूशन को डाइल्यूट करेंगे, डाइल्यूट करने का मतलब है अगर हम सॉल्यूशन का वॉल्यूम बढ़ाएंगे, अगर हम सॉल्यूशन का वॉल्यूम बढ़ाएंगे तो एक फॉर्मूला तो हमारे पास डायरेक्टली है, दैट लैम्डा m इज इक्वल्स टू कप्पा इनटू वॉल्यूम. ओके, इट मींस अगर हम वॉल्यूम बढ़ाएंगे तो मोलर कंडक्टेंस बढ़ती है. पर स्ट्रॉन्ग इलेक्ट्रोलाइट के केस में जो मोलर कंडक्टेंस है वो बहुत ज्यादा रेज नहीं करती, बल्कि आफ्टर अ सर्टेन डाइल्यूशन, बिकॉज नंबर ऑफ आयन इन पर यूनिट वॉल्यूम विल डिक्रीज. दैट्स व्हाई इन केस ऑफ स्ट्रॉन्ग लाइट इलेक्ट्रोलाइट मोलर कंडक्टेंस बहुत कम बढ़ती है, बट आफ्टर अ सर्टेन एक्सटेंट इट मे ड्रॉप अ लिटिल बिट, कम हो सकती थोड़ी. बट अगर हम वीक इलेक्ट्रोलाइट की बात करते हैं, अगर हम वीक इलेक्ट्रोलाइट की बात करें, इन द केस ऑफ वीक इलेक्ट्रोलाइट व्हाट हैपेंस ऑन द डाइल्यूशन, as soon as dilution increases, it means if we are raising the volume, because if we increase the volume, definitely solution will become dilute. On the dilution, degree of dissociation alpha increases on dilution. In case of weak electrolyte, it means if the degree of dissociation increases on dilution, the more number of ions will be produced. It means number of ion will increase. Number of ions will definitely increase in this case. So, in the case of weak electrolyte, on increasing the volume, or I say diluting the solution, molar conductivity increases. It means lambda m increases on dilution. There is a sudden change in lambda m. If we see the graph of this one, The graph can be drawn like this. Simple graph I am taking here. That is under root of concentration, and that is the value of lambda m. However, it is observed that in the case of weak electrolyte, in this direction concentration is increasing. So suppose that any concentration is over here. As we begin to dilute the solution, it means we are going back in terms of concentration. Okay. As we are decreasing the concentration, it means we are diluting the solution. If we are decreasing the concentration, molar conductance is increasing. And when concentration tends to zero, it means we are talking about infinite dilution. We are talking about infinite dilution. At infinite dilution पर जहाँ concentration लगभग zero है, molar conductance is maximum. At infinite dilution, molar conductance is maximum. Lambda m will be maximum. At infinite dilution, molar conductance will be highest for a weak electrolyte. So this graph goes like this. You can see this is the highest point of the molar conductance. This is for weak electrolyte. Like acetic acid, we discuss about. And for the strong electrolyte, the graph is like that. This is the strong electrolyte. Okay. So please remember, in the case of weak electrolyte on dilution, number of ion increases because degree of dissociation alpha increases, and that's why the conductance increases. And we can see that minimum the concentration, or we can say that maximum the dilution, minimum the concentration or maximum the dilution, the molar conductance increases. At infinite dilution, where the concentration tends to zero, the molar conductance is highest. When the concentration is zero, at this time, lambda m is called molar conductance at infinite dilution. That is called molar conductance at infinite dilution. So you can write here that lambda m at infinite dilution is equals to this one, lambda naught. Okay, here we are using a different symbol that is called lambda naught. Lambda naught means molar conductance at infinite dilution is denoted by this letter. And now we will see the application of molar conductance at infinite dilution. Now we will see some of the uses of molar conductance at infinite dilution. First, there is very important law about it, that is called Kohelrousch law. What is Kohelrousch law? As we see that at infinite dilution, molar conductance become maximum. जब हम सॉल्यूशन को बहुत ज्यादा डाइल्यूट कर देते हैं तो मोलर कंडक्टेंस बहुत ज्यादा बढ़ जाती है. तो एट दिस कंडीशन कोलराउश का एक लॉ है. कोलराउश का लॉ क्या कहता है? कोलराउश का लॉ कहता है कि किसी भी इलेक्ट्रोलाइट सॉल्यूशन की जो मोलर कंडक्टेंस है इनफाइनाइट डाइल्यूशन पे जो मोलर कंडक्टेंस है वो किसी भी एक आयन की वजह से नहीं होती है. इट इज ऑलवेज दी sum of the molar conductances of the ions. It means at infinite dilution, the molar conductance of the solution is individual contribution of each ion present in the solution. Suppose that we have an electrolyte. Say acetic acid is the electrolyte. So in that case, as per the law of Kohelrousch, molar conductance of acetic acid at infinite dilution, denoted by lambda naught, molar conductance at infinite dilution of acetic acid, it written is this way. This will be the sum of individual molar conductance of acetate ion plus molar conductance of hydrogen ion. So this is the Kohelrousch law, that molar conductance of the solution of electrolyte at infinite dilution is the sum of individual molar conductances of the ions present in the solution. That's Kohelrousch law. And now we will see some of the application of Kohelrousch law. Application of Kohelrousch law. Okay. First application is this: to determine the molar conductance at infinite dilution of weak electrolyte. Determination of lambda naught of weak electrolyte. Okay. Suppose we have given with the molar conductances of lambda H positive ions, lambda I say we have given with molar conductance of HCl, and we have given with molar conductance of sodium acetate, and molar conductance of sodium chloride. Okay, we are given with these values और हमें फाइंड करनी है molar conductance at infinite dilution of acetic acid. I say this one question mark. Okay, so how can we find out the molar conductance of acetic acid at infinite dilution when we are given with the values of molar conductance of HCl at infinite dilution and NaCl at infinite dilution and sodium acetate at infinite dilution? Since we know that molar conductance of acetic acid at infinite dilution will be like this. Okay, acetate ion plus molar conductance of H positive ion. Okay, so what values we have? We have lambda MHCl, lambda infinite or lambda naught HCl, that will be equal to lambda naught for H positive ion and lambda naught of chloride ion. ब्रेक करके लिख लिया. ऐसे ही हम सोडियम क्लोराइड को लिख लेंगे, that is lambda naught for the sodium ion plus lambda naught for chloride ion. Okay, and we have sodium acetate, lambda infinite or lambda naught for acetate ion plus lambda naught of sodium acetate. So anyhow we have these values will be equal to this one. Okay, and now we have to find out the sum of the acetate ion and the H positive ion. It means anyhow if we can add this one and this one, what we have to do to add on this one and this one? We can do one thing. This is the equation number 1, this is the equation number 2, and that's equation number 3. If we add equation 1 and 3 and less by equation number 2, so what happens? Na will cut off and chlorine will cut off, and we will remain with acetate ion and H positive ion. Let's see, I am doing this. Equation 1 plus equation 3 less by equation 2, and all we have got over here is, let's see this, lambda m H positive, lambda not Cl negative, there is a plus sign in between, plus lambda m of acetate ion plus lambda naught of sodium ion minus lambda of sodium ion, minus lambda naught for sodium positive ion and minus lambda naught of chloride ion. Okay, so eventually chlorine less, sodium and sodium minus, what we are getting? This one plus this one, and finally we have got that. Okay, this one plus this one. Okay, because we have to find out the sum of these ions, and by doing this calculation with the equation we can find out these ions. इस पर भी न्यूमेरिकल ला सकता है, ये क्या दो मार्क्स का न्यूमेरिकल या 3 मार्क्स का न्यूमेरिकल आ सकता है. आपसे लैम्डा इनफाइनाइट कैलकुलेट करवाया जा सकता है फॉर एनी इलेक्ट्रोलाइट बाय गिविंग सच वैल्यूज, और बड़ा सिंपल सा क्वेश्चन होता है, प्लस माइनस का इजी गेम. नाउ विल सी अनदर एप्लीकेशन दैट इज फाइंडिंग आउट द डिग्री ऑफ डिसोसिएशन. Okay, how to find out the degree of dissociation? Degree of dissociation can be given as alpha, and the formula for alpha is very simple. That is the value of lambda m for any concentration over the value of molar conductance at infinite dilution, that is lambda naught. Okay, this is lambda naught is molar conductance at infinite dilution, and that is lambda m. C is just to mention that it is for any concentration. It is simply molar conductance which we have found from this formula. Kappa is equal to molar conductance is equals to kappa into 1000 over m. ओके, तो ये वही मोलर कंडक्टेंस है. इन दोनों के रेशियो से इन दोनों की हेल्प से हम निकाल सकते हैं डिग्री ऑफ डिसोसिएशन. और अगर हमें डिग्री ऑफ डिसोसिएशन पता चल जाती है, वी कैन आल्सो फाइंड आउट डिसोसिएशन कांस्टेंट. डिसोसिएशन कांस्टेंट के इससे हमें डिसोसिएशन कांस्टेंट के का भी पता चल सकता है. अगर हमें अल्फा का पता है तो हमें डिग्री ऑफ डिसोसिएशन पता चल गई, और इससे हमें डिसोसिएशन कांस्टेंट के का भी पता चल सकता है. सो दीज वर द सम ऑफ द एप्लीकेशन ऑफ कोलरॉक्स लॉ. नेक्स्ट चैप्टर में हम स्टडी करेंगे फैराडेज लॉ और कोरोजन. तो ये दो टॉपिक के बाद चैप्टर के लेक्चर्स जो हैं खत्म हो जाएंगे. आई रिक्वेस्ट टू ऑल द स्टूडेंट्स, प्लीज वॉच द लेक्चर्स, एंड इफ यू हैव एनी डाउट्स प्लीज आस्क. कॉल करें चाहे जैसे, बट प्लीज पढ़ते रहें, बढ़ते रहें। बाय।